Hi pre-calc, we're back. Domain of an equation. We were just doing domain and range of a graph. Now we're going to do domain of an equation. This is more abstract. You don't have something to look at. So a domain of an equation, what it's asking, the question is, what values of x are allowed in the equation? What values of x are allowed? Are there any exclusions? Is there something that can't go in there? So that kind of idea. So the best way to think about this, and what I'm about to say is really important, and I'll stress it as I go through this, is if you have a fraction, you can't divide by 0. That's something you're not allowed to have. And if you have a radical with an even index, the radicand, which is the variables under the radical, must be, when plugged in, must be positive. Okay, I'm going to say that again as I do it because the visual people need to actually see it. Okay, so as I do it, I will say it again. So there is no fraction or radical with an even index here. So if it doesn't have either of those problems, then the domain is all real. Okay, so it's really the fraction or the radical. I hate to sound negative, but it's like if there's no fraction or radical with an even index, it's always all real, because those are the two areas where you'll have a problem. I'm not talking about logarithms or exponentials. I'm just talking about basic algebraic functions. Once we get into other things like trig, and there are lots of domain restrictions. All right, now here we have a fraction, so let's go ahead and factor the denominator. So since we have a fraction, we're not allowed to divide by 0, so we have to exclude. We have to exclude the values that would make it to divide by 0. So we are not allowed to have, I'll write this more than one way. You're free to write it as you want, as long as I can understand what you're saying. You can even say it in words. So I cannot let x be 2 or 3. I cannot let x be 2 or 3, which by default means it can be everything else. Now, if this is one way you can write the answer, or you can say it in words. You can say all real numbers except 2 and 3. Some of you that are very good with the notation, you can write it very fancy. So you have the whole number line, but you're excluding this and this, which means that you're allowed to have everything else. So the nicest way to write this answer, the fanciest way to write it, would be that you have this segment here, which is negative infinity to 2, but it doesn't include 2, so it gets a parenthesis versus a bracket. Including 2 to 3. Again, it's open on both sides, so it gets a parenthesis and not a bracket. And then 3 to infinity, which again is open here on this side. So this is the nicest way to write the answer. If you want to put this on the exam, I'll be like super impressed. But this is also fine, and words are also fine. At the end of the day, this course is going to move really fast, so at the end of the day, I just want you to get to the finish line. Fancy or not fancy, whatever way, just dragging yourself, whatever, just get there. Okay, let's do the next one. Now, this has a radical with an even index, so that means that what's underneath has to be positive. Okay, if you don't understand what I'm saying, let me just give you a quick example. In the past, we know we could do the square root of 4, which is 2, or the square root of 16, which is 4. But we cannot do the square root of negative 4. We cannot do the square root of negative 16. We would say in the real system that this has no solution. Okay? In the real system, you can't write 2i. I'm not in the complex system. Or 4i. I'm not in the complex system. I'm in what we would call the real system. In the real system, negative numbers are not allowed. They're not allowed. So that means that what's under here, we call this the radicand. If you're particular about words, what's under here is called the radicand, and that has to be greater than or equal to 0. And this is how you solve it. You actually say the x values under here have to keep the bottom greater than or equal to 0. And then you do the math on it, right? You just do the little algebra on it. You move the 7 over. You divide off the 2, which will leave you with a domain. When you divide off the 2, will leave you with a domain that x is greater than or equal to negative 7/2. Again, if you're writing it in that really nice, fancy way, and notice here that we are allowed to have it, the boundary value because of the bar. And if you're going to write it in that super nice, fancy way, you're going to say closed at 7/2 because that's included to infinity, right? Open is parenthesis, close bracket. Okay, so that's that one. So this can take any x value from negative 7/2 or higher. If it's put under here, I can actually solve for y. If I pick anything less than that value over here, if I put it in, I'll get no solution because it's not allowed to be negative under here. All right, I don't think I left enough room for this next one, so let me move it over so I don't squish it. All right, let me move it over so I don't squish this guy. We're gonna do this one on the end here. Okay, over here, got plenty of room to roam now. This is much more difficult than the previous one because if you notice, the previous one is linear, right? This is first degree. This is quadratic, which means this is going to be more difficult to solve. We're going to need a bigger tool set to do this. Same general concept applies, that what the radicand, the thing under the radical, has to be greater than or equal to 0. So that general rule still applies, but this is more difficult to solve. So we're going to factor it now. And we're going to find something called the critical numbers. The critical numbers are where you pretend for a moment that this equals to 0. It is an inequality in truth, but we're going to pretend for a moment it equals to 0 because the critical numbers are the boundary values. That's what they are. They're going to end up being your boundary values. Boundary values are the places where you chop up the number line, and the boundary values can be excluded or included. They can be open or closed. Okay, so this is the critical numbers are going to end up being your boundary values. So if you solve this, you're going to get plus or minus 5. That's when this equals to 0. All right, now since this has the bar, that means it can equal to 0. Just like over here, we had that this one could equal to 0. So that means that the boundary values are included. So what you're going to try to figure out then is which part of these segments are part of the answer. So you pick what we would call a test value in each of these quadrants. Okay, so a good test value for in here would be like -6. Here would be like 0, here would be like 6. And what you want to do with the test values is you can either plug them in here, this line, or you can plug them in here. It doesn't matter. What matters is that this has to be true. When you plug it in, it has to be greater than 0, greater than or equal to. Don't plug in a critical number. Don't ever do that. It's just a test value for this part. So if I plug in -6, it's 25 minus, I'm going to plug it in here, but either or is fine. You're literally doing 25 minus -6 quantity squared. You're trying to figure out if that's true or false. If you take a negative and you square it, it becomes positive. So this negative is actually this one. Okay, so as you can see, this is going to be negative, which means that -11 is not greater than 0, so this is false. Okay, which means this is going to be bad. You're going to notice when you plug +6 into here, you're going to get the same scenario. That is not going to work. But you'll notice when you plug 0 into here, that's true. By the way, if I wasn't clear, you pick any number in this segment. So anything to the left of -5. I could have picked -8, -7, -6, -200. It doesn't matter. It just has to be to the left. Anything in between here would have been fine. They all give you the same final response. So anything in here would have been fine. -4, -3, -2, 2, 3, 4. I mean, there's a couple in here you can grab. Well, there's actually an infinite amount of numbers in there, but we try to grab the easy ones. And then anything bigger than 5, 6, 7, 8, 9, 10, 200, whatever you want. All right, so what this means is that this is the part of the answer that works. So just make sure you write what your answer is. So the domain of this guy is going to be from -5 to 5. You can write it like this, which means it's closed, or if you prefer the other notation, you can write it like that. Okay, you don't have to write it both ways. Just pick a way and say it. All right, I just want to stick on this a little longer because this topic is, I notice students find this sort of like very abstract, so I try to help them a little bit more on this one. All right, this guy, let's first break this into two parts. Since this guy is under an even index, that means that what's under here has to be greater than or equal to 0. So for the top part, because it's a radical, sorry, I wrote that. I gotta write a 3 here. Okay, for the top part, because it's a radical, the radicand has to be greater than or equal to 0. If you solve it out, you get that x is greater than or equal to 3. For the bottom, since it's in a fraction, you can't divide by 0, so x cannot be 8, right? Because the bottom, this whole thing, this x minus 8 cannot equal to 0. The bottom cannot equal to 0. So that means specifically that the denominator cannot equal 8. Now try to put these two things together. See if you can write it. If you write the domain like that as two parts, I'll take it. But try to write it better than that. So this is the idea. X cannot be 8. And x is greater than 3. So when you're greater than 3, you're just going to jump over the 8. Okay, you're greater than 3, but as you're greater than 3, you still can't be 8. So if you write this in a fancy way, which is be nice if you do it, you're going to go from 3 to 8, but you cannot include 8. That's why it's open at 8. Then you go from 8 to infinity, open at 8, always open at infinity. If that's just too confusing, you can leave it as these two parts in your answer, and I'll be fine with that, okay? All right, now the difference between these two is now the radical is under the entire thing. Sorry, the fraction is under the entire radical, which means that the fraction itself has to be greater than or equal to 0. So the critical number, which we said before, was when this is equal to 0. A fraction is equal to 0 when the numerator equals to 0. If you never really thought about that, let me just say that real quick. People don't always think about that. 0 over 5 is 0. 0 over 7 is 0. 0 over 9 is 0. If the numerator is 0, the fraction is 0. It's when the numerator and the denominator are both 0, which is called indeterminate. That's something different, okay? But the critical number is when this is equal to 0. A fraction is equal to 0 when the numerator is equal to 0. So the numerator will be equal to 0 when x is 1. And we know here that x cannot be -5. That's more of a domain restriction because you can't divide by 0. So when I put it on the number line, I can't have -5 because you can't divide by 0. That's a restriction. And at 1, it's positive. Now, the reason why this is not simply done is because this is under the radical. So now I'm going to test this part. I'm going to make sure that this whole thing stays positive. So I'm going to pick test values like I did before. I got to watch. This video is getting really long, so I may have to speed up a little bit. Okay, I picked a test value of -6 for over here, so I'm plugging in -6. If we get cut off, I guess I'll just have to pick it up somewhere else. Okay, I'm just crunching out -6 really quick. Okay, I'm getting that 7 is greater than 0. That is true, so that works. All right, now I'm plugging in 0. I'm doing the middle one. I picked 0. You could pick something else in there if you want. I'm getting -1/5. That is not greater than 0. That's false. This guy's bad. Doesn't work. Okay, I'm picking 2 for the n guy. Ooh, we might make it on this video. That is true. Okay, final answer. Okay, the domain of this guy, we're going from negative infinity to, what is this guy? Negative 5. Not including negative 5. It's a domain restriction. Then from 1, including 1, to infinity. Ooh, I think I'm going to get this in. Okay, that's that guy. And I want to just do one more little piece in this particular video. This is not an even index. This is an odd index. If you don't recall, cube root of 8, that's 2. Cube root of negative 8, that's negative 2. You can put positives and negatives, and if you didn't know, you can take 0 on any of the radicals. Any of the radicals. Square root of 0 is 0. Fourth root of 0 is 0. But what I'm trying to point out is that odd indexes or roots take negatives. So there's no restriction. If this is an odd number, this one's easy for you, right? Easy for all of us. The domain is all real. It's everything. It can take everything. There's no restrictions on an odd root like there is on an even root. You can just write one of these answers. You don't have to write both. This means all real numbers, everything. Right? So there is no restriction like we have on the Radicand on this guy.